Okay, this is going to be a example derivation. I'm going to do it twice, once without derived rules and once with, and I'm going to show how to use the show neg disjunct strategy in this derivation. So we'll show the conclusion. We'll make assume ID dm. I guess, oh, sorry. Assume ID is all we want to do at the moment. So I'll do this once without derived rules at all, and in the course of, actually, do we want to do it that way? Yes. So we're going to show if p then s. Oops, we need to do that over here. What we want to do, we want to get the disjunction, and if we got this, then we could use add right and add to we could use add to infer that. Now, there doesn't seem like there's much we can do. We can bring in the premise, but we don't have either disjunct, or excuse me, we don't have the negation of either disjunct, so we can't do anything. Well, we're trying to show if p then s. If we get if p then s, we're done, but it's also the case that if we get if r then q, then we're done. So we're going to try to show that now. And again, we appear to be stuck. So we need to do a different sort of subderivation. We have one unused line. We have line 7. And we need to, if we could get the negation of either disjunct, then we could, we'd be in good shape. We'd at least be able to use it, and it turns out we'd be in good shape. So we're going to say show neg disjunct, and we're going to show neg disjunct of 7. So it doesn't actually matter which one we choose. So we'll just choose the first one for fun. So we're trying to show not this, right? So not if p then q. So we'll make an assumption, and we'll make an indirect assumption. We can't make a direct assumption. And now we're going to see, do we have any inference rule applications? Well, indeed we do. On line 4, we have the antecedent, so we can do modus ponens. We have q. Can we cancel? Yes, we can. We can repeat line 11, and that's an indirect derivation. So we have not if p then q. Now, why did we get not if p then q? Well, because, so we're going to use the line we just did, and this tells us it's going to interact with line 7. And it tells us that it's the negation of the disjunct, one of the disjuncts of line 7. So we can say MTP. And we'll get if R then S. Okay, good. Can we box and cancel? Not yet. But if we look, we can do modus ponens with line 9 and get S. Can we box and cancel? Well, we have not S, so we have what we need to box and cancel. So we'll do an indirect derivation. And we can button this up again. Then we got if R then Q because it would give us the conclusion. So what we're going to do is add the, oh, I did the wrong one. Oh no, no I didn't. That was what I wanted. And we're going to copy down 2, and we have an indirect derivation. We did line 5 because it's the consequent of 3. 3 is the left side of the conclusion. And that's a direct derivation. Oh, did I put it on the wrong side? I put it on the wrong side. And that is a direct derivation. So the main thing this example illustrates is this the use of show neg disjunct right here. Because we did it in order to do modus tollens, tollendo ponens, MTP with line 7. So that's doing it without any derived rules. Now let's do it with some derived rules, and again, we can pursue the show neg disjunct strategy. Now I want to show you something, well, okay, actually, so we have we can use the derived rule De Morgan's, which makes doing derivations of disjunctions much easier. So if you see what happens, we have not if P then S, or we have not the negation of this disjunct if P then S or if R then Q. And when we apply De Morgan's, this OR turns into an and the negation moves from the outside to each of the conjuncts. So queuing is something that you can do to make things go quicker, take fewer lines. You can apply more than one command on the same line. So you could say, I want to make an indirect assumption, and then I want to apply De Morgan's to the result of that, and we can get the same thing in one line. So queuing is just where you stack up a bunch of commands. So I'll do that in this derivation and comment on that. Okay, so we have this conjunction, and we're going to split it up. Okay, now one of the rules that I mentioned in the in the derived rules section of the previous lecture is the rule NC. It says if you have the negation of a conditional, you can have the antecedent and the negation of the consequent. If let's bring in the premise. So there's nothing we can do here right now. So we could, so we need to do a subderivation. And we need to do something having to do with threes. Well, if we're not going to use any more derived rules, we would have to do a subderivation. And show unneg is always the preferred subderivation, because when it's completed, we can box and cancel, and that's always what we want to do. Wherever we are, however deep you are inside a subderivation, whenever you complete an unneg subderivation, you can box and cancel something. Maybe not the main derivation. So that's what we would do if we weren't going to use any derived rules, but we are going to use derived rules. We're going to use the rule NC that I talked about just a minute ago with lines 4 and lines 5. And we can go ahead and split those up. Okay, and that's good. Now we look again, and we look like we're stuck. There are no good inference rule applications to be made because we've used line 2, we split up to line 3 and 4. 3 and 4 we applied NC to get 6 and 7, and 6 and 7 we've split up. So we've used all the lines except line 5 and 8, 9, 10, and 11, but we can't do anything with 8, 9, 10, or 11 by themselves. We have to use line 5. So again, here we would use the show neg disjunct strategy. Oh, wrong line reference. And we could say assume ID. And then we can use our P's and Q's. So we have 8, 13, modus ponens, and then we'll repeat R, and that gives us an indirect derivation. And we can then use line 12 and 5 with MTP, right? Why we did line 5? Because it interacts with line 12, particularly via MTP, and we get if R then S. And then we can use R, and we get S, and that contradicts 9. And we're done. In fact, we can even do this slightly quicker. We don't even need to use this show command. If you remember, there's the rule MC. It says if you have the sorry, MC is not so good here. Yeah, I misspoke. Yeah, there's something we could do more quickly, but it's more involved and not, so we're not going to worry about that. So this is about as quickly as we can do this derivation, and it's easier with these with the NC derived rules. But we use show neg disjunct either way because we have to use this, we have to do MTP with this, and to do that we need the negation of one of its disjuncts, and the easiest way right now to get the negation of one of those disjuncts is just to do a subderivation of it. So that's an example of show neg disjunct and also some use of derived rules. In the next videos, I'm going to be talking about truth tables.